Hi everyone, today's video is on lesson 33A. We're going to talk about parts of a parabola, and you may have seen a parabola before. That's what this graph looks like here on the right, and what you should do right now is just take the time to pause the video and to copy down this parabola. The fastest way to do this is to plot the roots, plot the vertex, and then make a parabola motion so that its end behavior is towards positive infinity. We're going to draw on this graph throughout each part because this video is full of vocabulary for parabolas, so take note of all the vocabulary, whether you highlight it or you star it or you put it in a word bank. Whatever you do to organize your vocabulary, that's what you're going to do in this video. We are coming back to this graph a lot, but you should copy this down in your notes right now. Okay, so let's start with the axis of symmetry. The axis of symmetry will always be a vertical line. So it's always going to be a vertical line in a parabola. And it's going to be in the form x is equal to some constant or some number. So let's take a look at the graph and see what is the axis of symmetry. If we are looking at this, there is a line right here that cuts right through the middle. And if you notice, it mirrors on the left and the right, and so it's symmetrical. So that's the axis of symmetry, and it happens at this line, which is x is equal to -1. Notice, x is equal to -1 is not the location of a point in this case. X is equal to -1 is an entire line. And we're going to have to get used to referring our formulas to and our equations to graphs now. We're going to start making that connection. So x is equal to -1 is a vertical line. On the graph, axis of symmetry is x is equal to -1. So in your notes, you should have axis of symmetry written down, and then you should also have this sentence with these notes next to it, and then you should have your parabola identified with the axis of symmetry. So in this case, I made it blue, and I circled it, and you should say axis of symmetry. Okay, the vertex. All of these parts are super crucial in parabolas, especially the vertex. I don't want to pick a favorite, but the vertex tells us a lot of information. The vertex is the maximum or the minimum of the graph, and it is in the form of some kind of point or coordinate on the graph. So it's going to be a coordinate. So if I ask you for the vertex, you're going to read an xy point off the graph. In this case, down here on the graph that you wrote in your notes, the vertex is vertex -1, -4. So up here on the graph, -1, -4. This vertex we'll talk about in the future, but it tells us a lot of information about maybe maximums and minimums, and in application problems with parabolas, this comes in handy. Sometimes the vertex is also a zero or a root, and we'll talk about what zero and roots are right now. So zeros and roots, and this means they have real solutions. If they have real solutions, I'll put a little note, real solutions, roots or zeros. Roots are also known as zeros, and I will use them interchangeably all the time. I'll say the zeros of a graph or the roots of the graph. They're also known as the x-intercepts. So you have to go look on your graph, where does the graph touch the x-axis, and you know that's where a root is. The roots are in the form x comma, nope, x is equal to, they're in the form x is equal to something. There's a couple ways to do this. So you could say that the roots are at the point x is equal to a value, or you can say it's a coordinate point, x comma y. You just have to be really clear, because if you wrote x is equal to some number, you have to say it's a root. And most of the time we're going to ask you for the root as a point, and which makes it really, really clear, and I'll show you why. So let's take a look at our graph. I'd love if this scroll down. Okay. In our graph here, our roots are located where this graph touches the x-axis. So this touches the x-axis at x is equal to 1, and this touches the x-axis at x is equal to -2. So let's write the roots or the zeros as a point. If I just had to read this point off the graph, I'd read as 1, 0. If I had to read this point, oh, this is -3, sorry. If I had to read this point off the graph, I would just read it as -3, -1, -2, -3, 0. So my x-intercepts are going to be 1, 0 and -3, 0. Notice, I want you to make a connection, and this is where you can annotate your notes. The x-intercepts, there is a value for x, and then there is a 0 for y. So over here, instead of x equals c, you can also write as x, 0 for the x-intercepts. For the y-intercept, sometimes we ask for y-intercepts, not always, but it's when the x-axis, it's where the graph touches the x-axis, intercept. So we would say that's, for example, when x is equal to 0, and then there's a y value. So on this graph here, it is at -1, -2, -3. It's when y is equal to -3, or more preferably, you can write it as 0, -3. That's down here. Okay, a range is an inequality, or it's some kind of interval, which means it's like a collection of y values. It starts at the vertex. Okay, let me explain what I mean. First of all, range is another awesome vocabulary word. You're going to hear it a lot, and you can always ask, what is the range again? Because it's one of those words that just gets asked a lot, and people tend to forget. So find the vertex on a graph to find the range. Our vertex is here. The y value, the range is always the collection of y values. Collection of y values. We start with the range at the vertex, and this is when y is equal to -1, -2, -3, -4. All of the values for this parabola is bigger than -4. This value of y is like -3.5. This value is -3. This value is 0. This value is bigger. All of the parabola is going to be either equal to 4, or it's going to be greater than 4. So notice how this is an inequality and this is an interval, which means there are lots of numbers that are greater than 4. All the y values are greater than 4. Notice that the parabola does not go below -4. That's what the range means. Okay, concavity. There's two ways to talk about concavity. We have concave up, and we have concave up and concave down. And you will probably hear this in all of your math classes. So concavity, the equation of the graph, because each graph comes with an equation that we've seen before, but the equation of the graph is, or I will say it this way, will have a leading, a positive, leading number. That just means the first number, or the a value of our parabola, is going to be positive. However, when it's concave down, the equation will have and by leading number, you've actually seen this before, and it goes right into standard form. But here's standard form. We've seen it since the first day of school. Y is equal to ax squared plus bx plus c. And if you are annotating your notes, one, I want you to write down in your notes, where else have we seen standard form? How else have we solved for it? Maybe successive differences. Maybe we've expanded factors. I want you to write down, where have you seen this before in this parabola in standard form? Because right now it's like a really big deal that we're going to take this standard form and we are going to make a graph with it now and finally make this nice connection of graph and a parabola in its equation form. Okay, so for concavity, it'll be a positive a value if it's concave up. So I'm going to go back here and make and annotate positive a value. And then for concave down, it's negative a value, which just means there would be a negative sign in front of this equation if it was concave down. In this case, this graph is concave up, so it has a positive a value. So our graph is concave up. A is positive. Let's hang in there. We have one example that we're going to work on together, but you had lots of vocabulary. Do not be surprised when this vocabulary comes up and you'll have to write sentences with it and use your math reasoning. And this is an appropriate time to ask questions about the vocabulary all throughout this week. But whenever you talk about a parabola, I do not want you to say this part or this part. I want you to be specific. I want you to say roots, concavity, vertex, range. These are all excellent words to use. Okay, example. Select, well, I'm going to pause this and I'm going to do a separate video. Okay, bye. Where do I go? Screencast.